Okay, so we're in 3.1 and it's called All Things Be Equal. And what we're going to be doing is solving quadratic equations graphically and algebraically. And up until this point, you've already graphed equations, and actually you solved some quadratic equations. We'll call them the simple ones. Your big job today is to make connections between solving quadratic equations and graphing quadratic equations. And then the question is how can we use graphs to solve quadratic equations? So that's our purpose for today, this lesson, okay? So it says, as we have learned, quadratic functions can be very useful for models for a lot of real life situations. They are part of our understanding of the motion of objects, business and economic models, and many other applications. But they're basically saying it's really, really useful. Using quadratic functions often requires solving a quadratic equation. This can be pretty straightforward process, or it can be really, really complicated. The good news is that we know a lot about quadratic functions, and we can apply that we can already apply to solving equations. Okay, so the very first one is, let's say I have a number. And when you square it, it gives you 9. So what are those solutions? So I already peeked in and I saw a bunch of you having really strong answers. Let me anonymize real quick. So I already saw a lot of you like, oh, I can square root it, both sides. Ooh, some of you use this factoring thing, very fancy. But all of you got these two answers, 3 and -3. You did not need to do all these, right? Just by looking at the prompt, right? What number, when you square it, gives me 9? And you'd be like, oh, it's 3, right? And then I'm like, okay, but shouldn't there be another number? And the answer is yes. So it should also be, so that's supposed to be a comma, -3, right? This is my great annotation skills with my mouse there. Okay. So let's continue forward. Then it says, now they want you to graph this function. So that's easy. Not easy, but that's doable because we just have this function here. We go x to the second. There it is. So there's the function. I'm going to pretend that I drew it there, right? And it says, for what values does f of x equal to 9? Okay, so I'm going to show you something, and I haven't shown you this yet. So pay attention. This is the part where you pay attention. So if I wanted to know when it's equal to 9, I can actually graph another line here called y equals 9. You're like, Ms. Johnson, it didn't change. I know, because it's above this little line here. So I'm going to bring this down. Okay, what do you see here? What do you notice in this picture? What do you see? What do you notice? What do you think is the most important part of this whole picture, this whole graph? Yeah, that they cross each other. Exactly. So the most important part is where they cross each other. Okay. So I'm going to use that to find my answers, right? So where do they cross each other? What numbers is that? Yeah, exactly. It's at 3. That's one of the parts right there. What's the other one? Yeah, the other one is at -3, 9. Very good. Right? So when I'm looking for that answer, it's basically this. It's at -3 and +3. Okay. So how did you find those values? What did you guys tell me what to look for? What did you guys tell me to look for? What should I look for? It says, how did you find these values on this graph? What did you look for? Wait, what did you guys tell me? And then I pointed, someone said, oh, it's at 3 and -3. What did you guys say? It's where they what? Not intersect, right? It's where they intersect. Okay, where they intersect. So can you write that for this answer? How did you find the line? Well, I graphed both of those and I found where those two lines crossed or those two lines intersected. Not sept, not the y-intercept, but sect, S-E-C-T, right? How do they compare to the solutions of the equations? Very good. So is everybody okay with this? So far, have I taught you anything new so far in this part? You guys are like, not yet, Miss Johnson, because we already knew that, right? You guys already knew, you already knew how to find the solution to a system. You just find out where they cross. Okay, where they cross, okay? Okay, let's do this next one. Given the equation, solve the equation algebraically. Okay, so this is going to take some remembering. Back in the day, this is probably in 8th grade, maybe 9th grade, depending on like, you know, what you learned. So this is what they're asking you. They're asking you, what is X? What is X? Can you give me a second? Okay, sorry. So I'm going to solve this equation algebraically. So the very first thing is, this is way back in the day. So can you just think about, I need you to think of a number that when I square it, it would give me 4. And then use that to figure out what X should be. Very good. Someone says, hey, Miss Johnson, when you square 2, it becomes 4. That's right. Right? Very good. Very good. Okay. So yes, when you square 2, it becomes 4. You're exactly right. Okay. So then we know that our answer is going to be somewhere in that neighborhood, but then I need to subtract a number to get back to that 2. I need to subtract 1 to get back to 2. So what number is this going to be? What number is this going to be? I don't know. Try it. Someone says, hey, Michelle, I think it'd be 3. So try it. Let's try it. All right. I'm going to use my Desmos graphing calculator. It's just me being silly. Graphing stuff. Okay. Let's go here. And here. Okay. So someone says, Miss Johnson, I think the answer could be 3. I don't know. Let's try. So 3 minus 1 squared. Oh, look, it's 4. Yay, you got the right answer. It's 4. Very good. Now, remember, there's another number that you could square that it could also be 4. There's another number that you could also square and it would also be 4. What number is that? When you square it, and it would also be 4. What number could that be? Yeah, very good. Okay, so if negative 2 could also be squared to give me 4, what number when I subtract 1 would get me back to negative 2? What number when I subtract 1 would get me back to negative 2? Does that make sense? Okay. So very good. So very, very good. Some of you are already figuring this out. Okay, good. So here's the point. You should know that there are 2 answers to this. So I'm going to solve this algebraically the way I expect you to do it. So it's x minus 1 quantity squared equals to 4. And so the method I want you to use is something that you know, but it's backwards. See if you remember this guy. Do you remember this guy? And I'm going to guarantee you most of your teachers didn't teach it to you this way because I think I kind of figured this out along learning it. Anybody recognize this guy? Yeah. This is PEMDAS, but it's not PEMDAS. What is this? It's backwards, right? It's in reverse order. So PEMDAS tells you how to simplify something. SADMEP tells you how to solve it. Say that with me. SADMEP tells me how to solve it. So all you're going to do is you're going to go through each of these and figure out where it is, and then you're going to do it to that. Does that make sense? So the very first thing is there any subtraction or addition? And someone says, yeah, Ms. Johnson, it's right there. Technically, is this subtraction? What do you see before that? What would happen before that? Yeah, he's in parentheses. So the very first thing I need to do before, so he's stuck in parentheses. I can't touch him. So, okay, so is there, what is this little 2? Where does he fall here? Where does that little 2 fall here? S, is it subtraction or addition? You guys are like, no, there's no subtraction or addition, Ms. Johnson. Is there division or multiplication? You're like, no, there's none of that. And is there an exponent? And you're like, yeah, that's an exponent, Ms. Johnson. Very good. This is an exponent. So how do you get rid of squared? Do you guys all remember this? How do you get rid of squared? How do you get rid of squared? Some of you did it on your Desmos. How do you, no. How do you undo squaring? No, actually, it's just the square root. It's just the square root. Okay, much like multiplying and dividing are inverses of each other, squaring and square rooting are inverses of each other. Okay, so you'll see these two would undo each other. Let me just prove that to you really quickly. Just, it's not proving it, it's just more showing you. Hey, what's the square root of 25? It's 5, right? Good. What's the square root of 5 squared? It's 5, right? So 5 squared is 25. The square root of 25 is 5. So do you see what happens here? They undo each other. So sometimes you'll see me using notation that looks like this, because I'm just showing you they undo each other. Okay, so it's just left with 5. So if you want to undo a squaring, everyone say it. I square root both sides. So these two will undo each other for sure. So I'm left with x minus 1. Now here's the part that you need to pay attention to, please. Please pay attention. Whenever you take the square root, you have to remember to put plus or minus. You have to remember to put plus or minus, because there's 2 answers coming out of there. I'll show you graphically why it looks like that. But whenever you take the square root, you took it. The square root wasn't in the problem originally. Do you see this? So then you have to take take the initiative to put a plus or minus. You have to think about both answers. Because remember when I said, hey, isn't there another number that when I square it, it's going to give me 4? And you guys all said, oh, -2, right? Okay, so the last little piece here is how do you get rid of this -1? And everyone's like, oh, just add 1 to both sides. Very good. Right. So then my final answer is x is equal to 1 plus or minus the square root of 4. And then I'm going to simplify this, but I just like to leave it like this. Even though this looks like a gnarly looking number, like Ms. Johnson, is that even a number? Yeah, it's a number. But anyway, so let me simplify this. So this is x is equal to, now, what is the square root of 4? What is the square root of 4? Yeah, it's 2. So this is 1 plus or minus 2. Now this isn't a weird number, like a new number. It literally means 1 plus 2 or 1 minus 2. So this is 3 or -1. These are my 2 answers. 3 or -1. Okay, let's review. Why did I take the square root? Why did I take the square root? No worries. You're fine. Don't worry. We're all learning this together. You're good. Wait, why did I take the square root? What in this equation tells me take the square root? Yeah, get rid of that squared, Miss Johnson. Very good. So here, what told me to get rid of the square root? I mean, sorry, what told me to square root both sides? That little squared right there. Got it? So go look over here at our homework, right? Let me see if I can find one really quick. Okay, look at these problems right here. Which one? Oh no, that's not correct. Sorry. I can't find one for you because they didn't tell you to do it like this. Oh, they kind of did, but it's hidden. It's okay. We'll look at it later. Okay. So this told me, the squared part told me, right? Get rid of that. Very good. Good job. Okay. Next part. Where did this plus or minus come from? Where did the plus or minus come from? Whenever I take the square root of both sides, I have to put plus or minus. Okay, you have to. Otherwise, the answer is not going to find itself. It's not going to be there. It's going to be like hidden. You're going to come out with one answer. Oh man, hold on. Try to make this pop out to you guys so you guys can find it whenever you're looking at my notes. There. So whenever I take the square root, I have to put that plus or minus. Okay. And then I added 1 to both sides. This is not some weirdo number. Some students think that this is a weirdo number. It's not a weirdo number. I just haven't simplified it yet. Shelton, why didn't you simplify as you went? Sometimes I don't like to, because I like to simplify at the very end. It's kind of a math habit that you get into, right? So just kind of be comfortable with looking at a number like 1 plus or minus the square root of 4. It's a number. In fact, it's 3 and -1, right? Okay. So any questions on solving it algebraically? Okay. I will just tell you right now, in a second, we are not going to take the square root of this one. And I want you to say, Miss Johnson, why not? Like, what's the difference between this one and this one? That's exactly the point. So you should be saying like, why not? Why can't we just take the square root of this? So just give that a second. Okay, the next part says graph the function of these two and mark the points where f of x equals to 4. So the way we mark them is we graph both of them. So I'm going to plug both of those in. So x minus 1, right? So there's my parabola. I don't know if you guys can see it. And then I'm going to graph the line y equals to 4. Does everybody see me graphing the line y equals to 4 right here? Y equals to 4. Everybody see this? Okay, let me take a snap of this. I'm going to ask you the same exact question. Where's the most important part on this graph? In this picture, where's the most important part? Yeah, exactly. Where they intersect. Thank you, thank you, thank you. Yes, where they cross, where the two things cross, where they intersect, whatever you guys want to say. I'm putting this right here because I gotta give you guys credit. Where it crosses, Miss Johnson. So later on, when someone says, Miss Johnson, I don't remember this. I'm like, well, you're the one who told me this. Remember? Oh yeah, Miss Johnson, I remember. Okay, so where they cross. So I'm hoping that they cross at 3 and -1, because if that's true, then I'm good. And it does look like that. Look, 1, 2, 3, up, -1. Up. Let's see. Let's actually look at the actual graph. Let's click on that. Look, it's 3. It's -1, Miss Johnson. It is right. We did it right. Okay, so let's go back to our goal here. Our goal said solve quadratic equations graphically. Do we know how to solve equations graphically? Look at this picture. Do you know how to solve it graphically? Everyone's like, yeah, because you already knew how to solve a system of equations. So I'm just turning this into a system, right? And you already know the most important part is where they intersect. And we know how to do it algebraically. This is you doing it algebraically. I'm going to show you another algebraic way in a second. Make connections between solving the quadratic equations and the functions. Yeah, there's definitely things here that we're seeing that are the same, right? And the last one is, how can we use graphs to solve equation? Did we use a graph to solve this equation? Did we use this graph to solve the equation? Oh, you guys are really quiet in the chat. Yes or no? Did we use this graph to solve this equation? Okay, yes, we did. Okay, so we're still a little bit unsure. Okay, let's do number 4 together. Okay, it says graph the equation this. Oh, given the equation this, graph the function and find where f of x equals to 1. Just to be efficient, use technology and record your graph here. Okay, so let's do this together. You're going to tell me what to do. Okay, I'm going to erase all this. You're going to tell me what to type in here. So it says, given this, graph this. What do I type in here, guys? Come on, y'all. I only have like 3 people participating. That's not enough. Very good. Where do you get? Oh, wait, what? Someone said graph y equals to 4. Yes or no? Looking at this information here, am I graphing y equals to 4? Yes or no? Very good. No. No way, Jose. Nope. No. For this last one, yes. Yes. For this one, no. Okay, so I'm so glad you made a mistake right here. Here's your participation credit. Very good. So what should I be entering then? Darn. What should I be entering? If I'm not going to enter 4, what should I be entering? Yeah, get in here, get your credit, get your answers wrong in here. Get your answers wrong in here. Okay, for those of you who got this wrong, now we're going to get it right. So y equals to 1, someone said. What? You want me to graph y equals to 1? Good. Where do I see y equals to 1? Where do I see y equals to 1? Yes, it's right here. This literally says y equals 1. Okay. The other part is that's the other side of the equal sign. It's the other side of that equal sign. Okay. Yeah, that's fine. No worries. No, I'm glad you're wrong. Because when you guys are wrong, even if it's a mistake, like, oh, I read it wrong or anything, who cares? Be wrong here. It doesn't cost you anything. Does it cost you anything? No, it doesn't. You're supposed to be wrong while you're learning. Learning is messy, right? If you're not getting it wrong, it either means this stuff is too easy or it means you're not trying. So I'd rather you be wrong. And it does not cost you your pride. Actually, you know what? If that's true, right? If that's true that I shouldn't be wrong in front of you all, how many times have I made a mistake? Yeah. And I actually record my mistakes. How about that? Hey, don't say a lot. That's funny. That's actually funny. Okay, so y equals to 1. What else am I going to graph? And then, by the way, it's down here. You see this blue line? What else do I need to graph? What else? Read the problem, guys. Come on. Let's go. You can do this. No. We want to, okay, the other time we graphed this and this, right? So this time I'm going to graph this. Graph the other side of the equation. Yeah, so I'm going to type it in. So negative x squared minus 6x minus 7. Got it? Where did she get this? Oh my gosh, where did she get this? She's just making stuff up again. Is Miss Johnson making stuff up again, guys? Where did she get this? Where did she get this equation? Yes, it's the equation. Exactly. Very good. It's right here, Miss Johnson. So you just want me to graph each side of the equation? Yes, that's what we did up here. And actually, that's what we did up here too. X squared and then a 9. X squared, 9. Then we graphed x minus 1 quantity squared and a 4. So here we graphed negative x squared minus 6x minus 7 and 1. Okay. And then it says, find my solutions. All right. Well, it says, graph the function and find where f of x equals to 1. Okay. So where is my solution, guys? According to this, where's my solution? Okay. And if you don't remember, it's right. Here's your answer. Where it crosses. So go ahead and write that. Where it crosses. Very good. Get that in. Okay, so what are the actual numbers though? Give me my solution. I want my solution. Someone says -2 is one of the solutions. Okay. So x equals, oops, sorry. X equals -2. Yes, very good. What's the other solution? What's the other solution? Yeah, -4. You guys okay? Are we thinking about vacation already? I know. Okay, so wait, Miss Johnson, those are my answers. Yeah. So wait, how could I check my answer? I'm so glad you asked, right? So what I'm going to actually do is I'm going to copy this again, and I'm going to plug in my values of -2 first. I'm going to do one at a time because x can only be one thing at a time. So -2 is my x, and then this is going to be -2. It's 1. Don't we want it to be 1? So everyone say, yes, we wanted it to be 1 because that's what the equation said. When does it equal to 1? Yay! So -2 is a perfect answer. Yes, on a test, Miss Johnson cannot take points away because it's perfect. Okay, so now I want to check this -4. So I'm just going to copy and paste this because again, I don't want to have to retype that. And then sometimes, I just want to make sure. So this is a 4, and I want this to be a 4 over here. When I hit 4 right here, what do I want this number answer to be? What do I want it to be? What do I want it to be? Yes, I want it to be a 1. Please be a 1, please be a 1. It's a 1, Miss Johnson. What does that mean? It means it's perfect. It means it's perfect. Okay, so let's just review really quickly because I want to finish this video. And then it says solve the equation algebraically. I'll show you how to do this in a little bit. So I'm not actually going to show you this. I'm going to show you this one, and then you'll be able to go back and fix this one. Okay. So this is the most important part, and I'm going to teach it to you fairly quickly, just so that we can get it in our heads and we understand. So if you're given the function this, and they asked you to find the x-intercepts, what quadratic equation would you be solving? Okay, so wait, what? You want me to graph it, Ms. Johnson? Yeah, sure, you can graph it. So you want me to just put that in there? Yeah. but this is something you already know how to do. I'm going to take two things that you already know how to do and put them together, and that's how you solve it algebraically, okay? So then they said, and they've asked you to find the x-intercepts. Wait a second, we already know how to do this. Remember, we talked about this already? These, whenever it's in factored form, remember, it's very useful to find the x-intercepts. Does anybody remember what our x-intercepts are here? If you don't remember, you can use this. What are our x-intercepts here? Yeah, it's 4 and -3. Wait. Ms. Johnson, is that a coincidence? Because I remember you talking about this, right? And I remember you saying, like, look, it's kind of like they're opposites. Well, kind of, right? No, it's not -4 and 3. It's 4 and -3. And I'll show you the reason. Okay, so here's the reason why. So this and this are exactly the same. So the very first thing that I try to do is I try to factor. So I'm going to ignore this right side and I'm going to look at this left side and I'm going to factor it. This is something you already know how to do. Now I only have a couple of seconds, so I'm going to explain this really quickly. Now look. I'm going to tell you something times something equals to 0. Something times something equals to 0. What was your favorite multiplication facts when you were younger? Which table was the best? Was it the 1s? Was it the 2s? It was my zeros. It was my zeros. Good. Why are zeros your favorite fact when you were younger? Say it. Someone say it. Yes, they always equal to 0. Very good. Okay, so we're going to use that fact. This is back when, y'all were little. So I'm thinking about like 3rd grade Robert, 3rd grade Jade. I'm thinking about all of you as little 3rd graders. Okay, so cute, right? Okay, so if I said, hey, something, now I wouldn't show you like this as a 3rd grader. I wouldn't do that. But something times something gives me 0. You would say, well, one of those would have to be 0. Oh, okay. So if this is true, then I can write this. If this is true, then I can write x minus 4 0 or x plus 3. What makes this 0? Excuse me. Excuse me. Yes, you're right. Handsome, not cute. My bad. What makes this 0? What number would make this 0? And you guys would be like, Ms. Johnson, x equals to 4. Very good. What would make this 0? -3. Okay, so this is where I'm going to pause this. I know I kept this a little bit longer. So when they tell you to solve things algebraically, they want you to first factor it. Now you've been factoring. That's what we did all last unit. You're really comfortable with it. One of your classmates came up with, okay, what times what gives you this? What plus what gives you this? Oh, Ms. Johnson, you want us to do the X problems on this? Yes. Okay. And then the next thing I'm going to do is I'm going to take you back to 3rd grade and say, what times what gives you 0? And you're like, well, I'm just going to make both of them equal to 0 and find out what values those are. Okay. Very, very good. So we're going to check these when we come back the next time, and then you should be all set. Very strong work today.